And we're live. We're talking about the 100% global renewable energy future that's just about to potentially happen. And hi.
Hi, I'm Andrew Blakers. I'm a professor of engineering at the Australian National University in Canberra.
And here, just one of your slides, you've done research to figure out how much energy storage is actually possible with the hydro, right? Pumped hydro?
Yeah, so pumped hydro is 99% of all energy storage around the world at the moment, but almost all of it's on rivers, and it's not a good idea as we need more and more storage to dam more rivers, and it's very easy to go off-river, and that means that you can build little dams of a few square kilometres each to dam very, very small micro creeks, and we found 23 million gigawatt hours of storage, which is truly enormous. It's about 100 times more storage than you need to support 100% renewable electricity for the whole world.
And here, for example, there's the USA. So you're saying that this whole area is pretty much like the mountainous area and not the flat areas, or?
Yeah, it's the Rocky Mountains on the west coast and the Appalachians down the east coast, with a few outliers in Texas and places like that. And it's basically unlimited. The USA has got 300 times more pumped hydro sites than it would ever need to support 100% renewables. In other words, storage is simply not an issue as we move to 100% renewables. It's off the shelf. Just go and buy it when you need it.
And so is there also the idea to do long transmission lines? For example, here connecting Texas with the West Coast, that might have the hydroelectric storage, for example?
Texas and the central part of the USA has got fantastic sun, fantastic wind, and not all that many people. I mean, most people live on the west coast and the east coast. So you need high voltage DC connectors to go from Texas to the northeast and Texas to the west. And I think a lot of people in Texas would have been very, very happy at the moment if those high voltage cables had been in existence, because they could have imported power during the recent blackouts. Texas is, for strange reasons, simply cut off from the rest of the United States grid.
Maybe I can start towards the beginning of your presentation. Recently, there's been the global 100% renewable energy declaration, and you're part of that declaration, right? Can you explain a little bit what it is?
Yeah, a group of people who spend a lot of time thinking about how to get rid of all fossil fuels, all oil, gas and coal, got together and looked dispassionately at what the options are, and have agreed that wind and solar are the runaway winners of the energy race. They are the future of energy, not just electricity, but energy, because you can electrify practically everything. And it turns out that we can actually go very fast towards 100% renewable electricity, then 100% renewable energy. And that means zero greenhouse gas emissions and zero local pollution as well from oil, gas and coal.
You're talking about 2030 or even faster, or what are you talking about?
We're talking about 2040 for zero fossil fuels. And on the way, we have to go through zero fossil fuels in the electricity system, and then electric vehicles push oil out of the transport system, and electrification heat pumps push gas out of heating, and then finally solar and wind together push coal and gas out of the chemical industry, so iron and steel, ammonia, and all these other things. And there's a group of about 8 of us who made this declaration, and we're getting widespread support from many prominent people around the world that yes, this is really the way to go. And we can do it fast.
So you're from around the world, right? Brian is from Denmark, and you're in Australia. Was it Finland?
German, a Finn, a couple of people from the US.
And from the Stanford, is he Mark Jacobson? And Tony Seba is a futurist, right? Or like he predicts the future.
Very prominent.
Nice.
Yes.
What is your hope right now? Are the politicians going? Everybody's talking about the Green New Deal. Everybody's talking about this kind of stuff. So is it really happening? And you in Australia, and I saw your presentation, you're saying that Australia is kind of like world leader?
Yes, surprising as it may seem, Australia has a fairly right-wing government, which you have to say has been very reluctant to embrace renewable energy. Nevertheless, the compelling economics of solar and wind are running right over the top of government policy and preferences, and they are really taking over. So if you perhaps go back to our slide. So this is the milestone, this is the national electricity market. This is where most people live. And you can see the green curve, that's the renewables. That's mostly solar and wind with a little bit of hydro. We're currently sitting at 30%. We're headed to 50% in 2025 and 100% in 2030. And as the amount of solar and wind rises and rises, then the amount of coal and gas falls and falls, and the price stays the same at $35 per megawatt hour. And if you go to the next one, the state of South Australia, it's even more remarkable what's happening there. So this is 1.7 million people, and South Australia is now sitting at 70% renewables. It goes down a bit in the winter, then in the summer it'll rise past where we are now, up another 10%. And we're headed for 100% renewable electricity in South Australia in 2025. Again, the price hasn't changed. It's $35 a megawatt hour. So this myth that solar and wind increases prices is simply wrong. Facts on the ground trump the modelling and the factoids promulgated by many people. And South Australia is now sitting at 70% renewables, has been for months, and is headed for 100% renewables in 4 years' time. And the price is $35 a megawatt hour. And that includes the solar and the wind and the storage and the occasional curtailment of the solar and wind.
How does $35 per megawatt hour compare with like old technology?
$35 a megawatt hour is actually lower than the cost of electricity from the Australian fossil fuel system. And that's the reason why solar and wind is running right over the top of coal and gas. It's pushing it out. So this is a good graph that shows this. This is the US dollars wholesale spot price. That's the blue bars, and the red curve is the renewable energy fraction. So in the national electricity market, it's up to 30% now. And you can see that the current price of renewable electricity is around $35 US per megawatt hour. And that's actually lower than the average over the last 4 years. So renewables really took off in Australia from about 2019 onwards. And the more solar and wind comes into the electricity system, the lower the price gets. It's not the higher, but the lower. So solar and wind really is the best way to go. It's cheaper. It's hands down winning the energy race. Plus, if you go to the second slide, I can illustrate that right up the top of the presentation.
So the next one or this one?
The second in the whole set.
The second, yeah. Sorry, let me go back.
Yep,
right there.
Right. So this is global annual net new generation capacity. So this is all of the generation capacity, solar, wind, all the other renewables, coal, oil, gas, nuclear, for the whole world. And in 2019, solar PV was nearly half the global total, and wind was another quarter. So solar and wind together in 2019 were about more than two-thirds of all of the new generation capacity installed in the whole world put together. And then hydro, with a bit of bio, geo and others, was occupying another section. And wind alone was more than all the fossil and all the nuclear new generation capacity installed globally. So solar, PV and wind have won the energy race. They've just won it. That's where the future is going.
So that means globally, you're talking China, India, and anywhere, US, Europe, the whole world. Now the renewable is more of all the new installations.
Yeah, much more. And this is 2019. The new data for 2020 will be out in about a month. And I expect to show that solar and wind together are 70 to 75% of all new generation capacity in 2020. Coal is falling through a floor. Nuclear is hovering around 1 or 2 new gigawatts per year. It's just trivial. And gas is also falling. People who are engaged in solar and wind are doing extremely well in their share markets, and It's because people realise this is the future. So in Australia, which is the global leader in terms of new capacity per capita, you can see this graph, which shows the new watts per person per year of renewables. So Australia is doing about 250 watts per person per year of renewables, which is about 10 times faster than the global average, 4 times faster per capita than in the US, Japan, China, and Europe.
But all these other ones, they need to catch up, right? And
that's right, yeah.
And but as you were saying, this is not really politics. It's more like common sense, and like is just about money. Or how did Australia do this thus far?
It wasn't any federal government plan, I can assure you, because the federal government is hostile to renewables. You have to say that. Not quite as hostile as the previous Trump administration, but the fact is that the compelling economics of wind and solar in Australia runs right over the top of the federal government policy and preferences. It just wins on the ground on a pure economic basis, hands down.
Is it like the regions who think it's making more sense, that they don't even need to ask the government?
The federal government is becoming fairly irrelevant, actually. If you're a minister in a state government and someone comes to you and says, do you mind if I spend $1 billion in your state on a new solar or wind farm? Then, of course, you say yes. But it's not state government incentives. It's simply that the economics of wind and solar are better than the existing gas and coal. And so people go and build the solar and wind farms and push gas and coal out simply because the solar and wind's cheaper. Additionally, Australia has about nearly 30% of Australian houses now have solar on their roof, solar photovoltaics on the roof. And these are 5 to 10 kilowatt systems by the million. And the federal government and the state governments have nothing to say about what happens there. It's the rooftop is owned by the individuals. And it's simply cheaper, much cheaper, about 1/3 the price to get electricity from a solar on your roof than it is to buy it from the grid. And so people go and put it on their roof.
And so there's no need to finance this in Australia. Like they don't need the government to come and say, we'll pay for it upfront and you just pay a normal rate for 5 years or something, or 10 years, and then it pays off for the installation.
No, none of that. All gone. No, the subsidy, there's a few residual subsidies at a very low level that are tailing off to zero over the next few years.
But many times when I hear conversations on the internet, people saying, but the storage is going to be too complicated. But are you saying the easy way to just store the energy is just doing pumped hydro power?
That's right. There's 180 gigawatts of pumped hydro around the world already. It's 99% of all energy storage. There's nothing to invent. You just ring up one of the hydro companies and say, I'd like one. The twist that you need to consider is off-river pumped hydro. Instead of putting hydro on the rivers, off-river pumped hydro is really useful. So you have 2 reservoirs, about a square kilometre or so each, located at a height difference of about 500 metres. Perhaps if you could just go back to that graphic you showed before of the... So you can see an upper and a lower reservoir. A few square kilometres each, 500 metre height difference between them, and you simply connect the upper and lower reservoirs with a tunnel, and in the tunnel is a generator set that if you can also run backwards to pump. So when you've got lots of solar and wind in the middle of the day, you pump water from the lower to the upper reservoir, and when you need the energy back in the middle of the night, the water simply comes back down through the tunnel and generates the electricity, recovers the energy. So we did a global search. We searched the entire world for these off-river pumped hydro systems, and we found about 40 or 50,000 in the United States, 600,000 around the world, and with about 100 times more storage capacity than required to support 100% global renewable energy. And this is completely off-the-shelf technology. In other words, storage is not an issue unless you happen to live in Denmark or the Netherlands. If you live in almost every other country, even flat and arid Australia has vastly more pumped hydro storage, off-river pumped hydro storage than it actually needs. And the US is spoilt for choice. So many sites in the US.
I'm a little bit from Denmark, right? And so, but they're talking about storing in hydrogen, maybe producing a whole bunch of hydrogen, and it might not be as efficient. I guess the pumped hydro is more efficient storage, or
storage in hydrogen is a wretched technology because it's only got a 25% efficiency. That means that you put 100 units of energy into your hydrogen storage, you only get 25 units back again when you turn it back into electricity. Whereas pumped hydro and batteries are 80 to 90% efficient. And this kills the economics of hydrogen. It just kills it. Pumped hydro is the way to go.
But what can Denmark do if they don't have any hills? Like the country's flat.
Denmark is a state in Europe, and Europe has vast numbers of hills. So Europe as a whole is absolutely not short of pumped hydro sites. Absolutely not short.
So you would just connect Denmark with the Germany or France or something, and then
yeah.
If I understand correctly, 1,000 kilometers, you might lose 3% of the energy. Is that correct?
Yeah, high voltage DC is completely off the shelf. State of the art is 12 gigawatts, 3,000 kilometer long cable, losing about 10% of your energy. So you can transmit from South Europe to North Europe. You can transmit from West Europe to East Europe. It's just off the shelf. You just go and do it. There are some not in my backyard problems of people not wanting high voltage power lines going past their front door. Well, I'm sorry, but it's either that or ruinous climate change. Take your pick, your view or your planet.
These high-powered voltage lines are like the standard technology has been around for a long time, or is like a new versions of it to make this work?
It simply gets better incrementally. So this year will be better than last year, better than the previous year. So it's not a revolution, but the technology exists, and it's being used, for example, to bring solar and wind power from the west of China to the east of China with several thousand kilometer span. And the same thing can be done to move power from Texas to New York or Texas to California and back when Texas has a problem.
When I look at this presentation, it might not have all the things you would be talking about, but here they're talking about potentially connecting the Middle East or Africa with Europe with just power lines. Is that, and so you could take the solar power from Africa, from the Middle East, and just connect it with, like, is that a good idea?
Yes. The more strongly you interconnect, the less storage you need. So if you connect over a million square kilometers, you can reduce the amount of storage you need by an order of magnitude compared with a little country like Britain or Denmark or Italy. And the reason is that you smooth out the weather. So if it's cloudy and no wind in Italy, then it might be very windy in Norway or sunny in Spain. It just makes sense to have the power lines to move the energy from one place to another. It just simply makes it makes the whole grid work much better. And connecting north to south means that you get rid of a lot of seasonal storage, and connecting east to west means that you reduce the amount of storage you need for the evening peak period, because it's still sunny to the west of you.
Would it make sense to connect Australia this way there? Is it connecting to Indonesia, or?
There is a serious proposal to connect a 10 or 20 gigawatt cable from the Northern Territory, northern part of Australia, through to Singapore via Indonesia. And there's also serious proposals to connect the Philippines and Papua New Guinea and all the other Southeast Asian countries to Australia and China and west to India, in order to take advantage of the good wind and good sun in this or that place, or the good pumped hydro opportunities, storage opportunities here and there. And it simply makes sense.
And here there would just be like a connection directly all across the US from one side to the other.
Yeah, and down to Mexico. Mexico's got pretty good sun, and South America is the same. Fantastic solar resource on the west coast of South America, Chile, and then you've got the Andes, which have unlimited pumped hydro storage all the way up the mountain chain, and you connect that to the big cities in the east, in Brazil and Argentina, and the whole system works better and better. And there's another big advantage of connecting regions of the world. It makes it much harder to go to war, for example, because if you go to war, then you get your electricity cut off, And it's just good to connect countries so that they depend on each other. Integrates everything.
You have to do like the internet, right? So there's like multiple options, right? Could go this way or could go that way. If somebody wants to cut off the cable, then you go another way, right?
If you cut off my cable and stop supplying me with electricity at night, well, I'll cut it off and stop supplying you with electricity in your night. So it doesn't work.
Here, Africa has got a huge sun potential. Yeah,
in the north of Africa, there's completely unlimited sun. It's also got fantastic wind. Although it has to be said that Europe, the North Sea in Europe has got vastly more wind than it could ever use. So, in fact, all regions of the world have got vastly more sun and wind than they would ever need, like a factor of 100 times more than they would ever need. And that's when they've applied everything.
This is not your presentation, right? It's just one that I saw on the internet from Bjarke Ingels, the Danish, what's it called, architect. And they're talking about that you could potentially have the south of the planet supply the north. When it's when there's summer on one side or the other, then they could supply each other and even out.
Yes, that's certainly one way to do it, although it turns out to be easier to do it on a slightly less grand scale at the moment, and that's simply to use solar and wind, because it turns out that the wind blows better in the north in the winter when there's not much sun, and 3/4 of the global population lives in the sun belt. That's plus or minus 35 degrees of latitude, and for these people, solar is always available. And there isn't really a winter dip, and you don't actually ever have a shortage of sun. And there's so many options with solar and wind that the storage is not a problem, the interconnection is not a problem, and the supply is not a problem. And the cost is right now. The price just keeps coming down.
And so one of the big, is it a big investment? Because I checked on the internet, and the dams were invented by the Egyptians like 3,000 years ago or something, right? But how about all those dams that are out there right now compared to what you're talking about off-river? What's the difference? And we don't have all these off-river pump systems yet, right?
We certainly have some, this is an example of an on-river system. So you can see a dam, and the water can go down through those pipes through the turbines, or you can make the turbines run backwards by supplying them with electricity and pump water back up. So this is a way of storing water. But off-river systems are vastly more prevalent. And the simple reason for that is that 99% of all of the land in the world is not near a river. So if you only confine yourself to rivers, then you've thrown away 99% of the possible sites. And certainly in Australia, because of the rapid rise of solar and wind, we have to worry a lot about storage very quickly. There's a dozen serious pumped hydro proposals in Australia. There's one being constructed which is actually bigger than all of the batteries in the whole world put together. That's called Snow 2.0. And of this dozen new hydro proposals, not a single one requires a new dam on a river. They're all non-dam proposals. This is a Google Earth synthetic image of an existing off-river pumped hydro system. So you can see that there's two artificial reservoirs at the top and bottom, 500-metre height difference in between, and there's a tunnel connecting them. And the water simply shuttles backwards and forwards. Each of the reservoirs is about half a square kilometre, and it's got a gigawatt power rating for 6 hours. If you make the reservoirs a little bit bigger, you can run a gigawatt for 24 hours, which gets around the day-night problem of solar. So it's just very straightforward.
How much power is that? When you're talking 1 gigawatt power for 6 hours, is it a huge amount?
Roughly speaking, if you go 100% renewable energy, not just electricity, but energy, that means no oil, gas or coal, you've electrified everything, you need about 20 kilowatts per person. And so that's about 50,000, the power required for 50,000 people.
And here you're zooming in on the Western USA. Is that suggestions for pumped hydro or?
Well, the Rockies has got unlimited pumped hydro opportunities. And if you go to our website, you can actually go and explore the pumped hydro in your backyard. So go to a place that you know, and you can zoom in and in and in, and each of those little dots resolves into a upper-lower reservoir, and with a lot of details in a pop-up of the volume of the water, volume of the dam wall, volume of the energy that could be stored, and so forth. So you can just go and look, if you're building wind or solar farm, you can just go and look for a pumped hydro site in the vicinity of your solar or wind farm.
What is it called, the website?
If you search RE100, standing for Renewable Energy 100, at ANU, you'll find a link fairly quickly to our website.
Yeah, I'm loading it right here. And then is that the Atlas?
Go to the Atlas, that's right. And then go scroll down.
Yeah.
No, not the Wind Atlas. Back up. The Offshore, the Pumped Hydro Atlas, the one above.
Where do I see that?
Underneath
there.
home. That's it. Yep. The Offshore Wind Atlas is a wind atlas for offshore wind farms. So there you can see the global map, and if you go down and hopefully click here.
Is it this one?
Yep.
Direct link to RME?
Yep.
Okay. And there you have a map.
Now you're loading the globe, and it'll ask you for to accept some disclaimers. Okay. Hopefully it's working today. Oh no.
No.
I'm sorry, the link must have broken. We're migrating. Oh, there it is. Yes.
Yeah.
And
so
now zoom in, scroll in, choose a place that you are familiar with.
Okay. Let's zoom in.
You can drag the map sideways using your mouse.
All right.
And you can just zoom in and in. And if you keep zooming, you'll see that these dots resolve. The red dots are the best. The light yellow dots are the not so good. There's a factor of 2 difference in the cost of a red dot compared with a light dot.
So if we go around here, the Hong Kong, Shenzhen area, there would be. So how do you get to these results? Did you have to, like, you have some kind of database of all the structure of what's called the Earth?
Yes, we have the Landsat images of the Earth, which is on 30-meter resolution and 1-meter vertical resolution, and we simply surveyed every square meter of the whole Earth, looking for potential off-river reservoir sites. And then if you just keep scrolling in to choose one site and just keep scrolling in, and you get more and more detail as you scroll in. And if you click on that red dot, you'll get a pop-up which tells you about the reservoirs. And if you dismiss that and click on one of the reservoirs, you'll get a pop-up about that particular reservoir. So you can see that's got a head of 500 meters. And if you click on one of any of the reservoirs,
Is it this one?
Yeah, so you can see what that reservoir is. And you can see the latitude, longitude, area, the volume, the dam wall height, the dam length, the dam volume, the water to rock ratio, which is the amount of water you can impound for a given amount of rock.
Is that the gigawatt hour also show on here, or
if you
how do you calculate that?
Click the red dot, and that tells you the reservoir pair. Just dismiss that top right. Yep. Click on the red dot. And you can
here's
see
energy gigawatt hour, 150. That's a
and
lot.
if you go, that's a huge. If you go to the left-hand pane, keep going left, you can choose a different size. Just click, and get rid of the 150. Otherwise, it'll be just choose one. Otherwise, it's they're on top of each other.
Okay.
Yeah, so that's now 50, and it's somewhat smaller because it's and then you just zoom in and same deal.
So is China going to do all these pumped hydro?
Oh no! I mean, China has got the most potential in the whole world. It needs about one in every 500 would need to be developed when China gets to 100% renewable electricity.
So they just need 1 in every 500 that you are suggesting here, right?
Yeah, that's right. So 99 point something of them, 99.2 of them will never be developed. Just the best 1 in 500. For Europe, it's about Europe's got about 100 times as many as it needs. The US has got about 300 times as many as it needs.
There's a lot of dots on this map.
I know, and they gradually resolve. There's a lot of sites.
So,
and this is the Himalayas, so it's not surprising that there's a lot of dots.
I don't know how many people there are around the Himalayas.
Yes, but you can transmit the electricity wherever you like. So perhaps go west to Europe and have a look at South Europe. Like the EU is not short of pumped hydro sites. Denmark is definitely short of pumped hydro sites, but EU as a whole is not short.
Over here in Italy, there's a whole bunch.
Yeah, there's
France,
lots.
south of France, the Alps.
And then poor old Germany, the Low Countries are not so good. But Norway has got fantastic opportunities, and Scotland's also got some pretty good opportunities.
So we just connect the flat parts to the mountainous parts, and we are all resolved, all solved. We don't need to wait for Elon Musk to create like super batteries that can be installed everywhere. But I mean, it would be a mix. You also need those?
Batteries are great for short-term storage. But the important thing to bear in mind is that you actually need long-term storage as well. That means days to weeks. And the water is the working fluid for pumped hydro. That's available everywhere. Whereas complex chemicals like lithium and cobalt are not in unlimited supply. And in fact, you're better off using batteries for short-term storage and pumped hydro for long-term storage for environmental reasons. So this is just a table of what's actually happening in Australia, facts on the ground. A lot of people talk about batteries. Batteries will be certainly important. But when you look at what's happening in Australia, where the energy transition is happening much faster than in any other country, it's a mixture of transmission batteries and pumped hydro. So the Snowy 2.0 scheme that you can see there under construction has more energy storage than all of the batteries in the whole world put together. So it's horses for courses. So batteries are great when you need sub-second to an hour or so of storage. Pumped hydro is great when you need overnight storage and day-long storage for seasonal storage, for example. And
there's some information about the Snowy 2.0?
Yeah. I mean, this is 2 gigawatts for a little country of 25 million people. Translated to Europe, that's like 50 gigawatts.
How much does it cost to build this?
Roughly speaking, if it's part of a major program where you're building one after another, so your workforce gets really skilled, you're talking about $1 billion per gigawatt for 24 hours of storage. So for a whole day of storage and a gigawatt of power, $1 billion US.
Do you want to have a few days of backup just in case something really strange happens? Or
yeah, like Texas could have done with a few days of backup. It could definitely. And Texas is not short of pumped hydro storage, or just to the west of Texas, there's fantastic pumped hydro storage everywhere.
Are other countries doing a bunch of these pumped hydros, or are they just not yet, or what's the status?
Not yet. A lot of people are thinking about it, and the reason they're not doing it yet is that you don't need it until you get up into the 30 to 50% range and more of solar and wind. Well, Australia is at 30% renewables now, 25% solar and wind, and we need it. We will need it a lot in about 3 to 5 years. And other countries will arrive at the same conclusion when they follow in Australia's footsteps. And I really hope that that happens over the next couple of years.
So Australia is pretty much like just doing it because it needs to. It's not like a political choice.
If the government stands in the way of the storage, then we're likely to get blackouts, and that will reflect badly on the government.
There was some blackouts in it was in South Australia where Elon Musk came and said, "Hey, I'll build you a battery." And what is that? Is that just for like an hour of storage, or?
Yeah, that battery has got about an hour and a bit of storage. What happened was that we had a Category 2 hurricane go through South Australia, which was unprecedented. It brought down 20 high voltage power lines, and basically the system collapsed. It was back online about 6 hours later, and a lot of lessons were learned, and it has not been repeated. But in the 5 years since then, South Australia has gone from 35% solar and wind to 70% solar and wind. So we learned our lessons, and it's a good chance that we'll avoid that sort of thing happening in the future.
What are we looking at here? Is that the Snowy 2, or it looks like a conventional dam? Or
that's a catchment dam lower in the Snowy scheme. There's already a hydroelectric scheme in the Snowy Mountains. Snowy 2.0 is connecting 2 existing reservoirs with an underground tunnel and power station.
And then the power in Sydney and all the different places in Australia is going to be fine? Is that the...
It's specifically being built because rising solar and wind requires storage. And the cost of the storage is relatively small compared with the cost of the solar and wind, but you do need to build it.
So it's small. And how is it compared to the transmission?
Transmission, again, is a fairly small component of the overall cost of a solar wind system, but transmission is the most difficult in terms of getting permissions because you traverse hundreds of farms to go from one place to another. You can build a solar or wind farm or a pumped hydro system just by talking to a couple of landowners, but you can't build a transmission system without talking to hundreds of landowners. So there's lots more opportunity for pushback, and that's the most politically difficult thing to get built.
I think there's always some talk about the ecological risk sometimes of some dams and stuff like that, but can it also be positive? Like they could be like fish where there wasn't a river, there wasn't a lake before.
The vast majority of the pumped hydro proposals in Australia are not on any river. There's almost zero ecological impact. So these are a few square kilometre off-river dams in farmland a couple of kilometres apart. There is no environmental impact of any significance.
Is it difficult to build them and make sure that the water stays where it should be and it doesn't just evaporate or goes away or it goes into the ground? Or
no, these are just oversized farm dams which people build every day. The technology is exactly the same as building a farm dam or a mining tailings dam. It's simply heaping rock from the up to make a dam wall and then building a tunnel to connect an upper and a lower reservoir. This is completely standard industrial technology. And
so we are, can you talk a little bit about your background? I saw the introduction on the global 100% renewable energy, that you are involved with the solar power, and you have some world records in terms of energy efficiency and also inventions that are in all solar right now.
Yes, so I'm a silicon solar cell technologist. I did my PhD in that field quite a few decades ago. I produced the world's first 18, 19, 20 and 22% efficient solar cells. I was the lead author on the first 3 papers of the PERC solar cell, which now has 3/4 of the global solar market, and annual sales, cumulative sales of about 60 billion US so far, and hopefully headed for the $1 trillion over the next decade as solar takes over the world's energy supply.
So how does this PERC work? Maybe I'll just Google here. This what is special about what you did there?
The PERC technology is a way of avoiding the losses at the back surface of a solar cell caused by direct metal contacts. And so we developed a way of bypassing those losses, and that pushed the efficiency up. So it took quite a couple of, 15 years or so between the invention and the widespread uptake of the technology. But now the PERC solar cell dominates global solar production and hence global energy production. PERC is actually being produced faster than everything else in the whole world put together, all of the other renewables and the fossil and nuclear together. Of course, many people are involved in taking a laboratory idea through to very large-scale commercial production.
So are you in in this graph, right? Somewhere there.
Yes. If you have a look at the silicon chart, you'll see that UNSW where I was. Just trying to see where it is.
Is it this one?
Yeah, that's right. So all of those were mine. Those cells there.
So those were the best in the world at that point.
That's right. Yeah.
What's the efficiency right now?
The
best.
The best efficiency is 27+%. The theoretical limit is about 29%. So the best lab cells are closing on the theoretical limit, and the best commercial cells are above 25%. So we're really getting the juice out of silicon. And then there's a whole bunch of new technologies on the horizon that still need a lot of work, called tandem, that promise to push us over 30%. But it must be said that they're quite a few years away, I think, before large-scale production happens.
I've done a few videos with some suppliers that have been talking about trying to do, if I try to just find this one here, one example, they're trying to do like flexible solar. Do you think this is a potential huge future where maybe you could like print them out with flexible electronics and put them on like wallpaper or something like that?
Conformable or flexible panels are certainly interesting for solar roofs on cars, for example. But it has to be said that over the decades, there's been dozens of pretender technologies that seek to take on the crystalline silicon solar cell, and all of them have failed. Every single one of them.
It's not as efficient, right? The efficiency is lower?
The crystalline silicon is just a fantastic material. It's stable, it's bankable, it's vastly produced, it's got all the advantages of incumbency, it's efficient, it keeps reinventing itself, the efficiency keeps rising, the costs keep falling. It's just really hard to beat something like that. It's quite similar to electronics, where for the last 30 or 40 years, there's been all these pretender materials that are going to outpace the silicon chip. Well, it doesn't happen. The silicon chip just keeps going. In the same way, the silicon solar cell just keeps going, keeps getting better, reinventing itself. So it's very, very hard to overcome silicon.
It's also maybe to do with the reliability. You want to have something that lasts a very long time, right? I don't know how long these are going to last, the flexible ones.
And also, why do you need flexibility? You need flexibility if you want to wrap it around the curved surface of a car, but or if you want a mobile, something for military or bushwalk, camping or something like that. But even silicon has flexibility. If you don't package it behind glass, it's flexible. And the reason why you want to package behind glass is it doubles the lifetime. And so, people use glass modules because they last a lot longer. They last 30 years, 40 years.
And then I also did the video with these guys. They're doing solar windows. What do you think about that? Because there's a lot of buildings, and maybe they want to have some kind of shade, and then at the same time produce some energy through the window.
Again, it's a niche technology. People want to look out windows. Windows aren't in the direct sun, so they generate very little energy anyway. I was actually involved in the sliver technology. I was a co-inventor of that, which was the subject of a $250 million effort by Micron and Origin called Transform Solar. That had excellent clarity of transmission through glass, and it was made of crystal silicon, but it failed because it wasn't quite the same as normal crystalline silicon. So it's just so hard to beat such a powerful incumbent as ordinary crystalline silicon.
Couldn't it also be have to do with the potential of lowering the cost of making the solar systems if you can just print them out with like some kind of inkjet?
It doesn't matter if they're free. Only about a quarter of the cost of a complete solar farm is the silicon solar cells. So even if your solar cells were free, if your efficiency is not nearly as good as the silicon, then you're going to fail. Because you've got to encapsulate them, you've got to transport them, you've got to mount them, you've got to buy the land, you've got to fence the land, you've got to interconnect it. All of this doesn't depend on the cost of the cell, but it does depend on the efficiency of the cell. Because if you've got a higher efficiency, you need less of everything else. And this is the reason why flexible everything has failed. It's simply not as efficient as glass crystal silicon. So this is a graph which shows Australia's march to zero emissions in 2040. So no oil, gas or coal. So back in 2015-16, Australia was producing about 1 gigawatt per year of new solar and wind. In 2020, we're up to 7 gigawatts. So that's already a factor of 7 increase. If we push up to 14 gigawatts per year, then we get to zero emissions in 2050. And if we triple what we're doing now, we get to zero emissions in 2040. So we've only got to triple from what we're doing now to completely eliminate fossil fuels from our entire economy in 2040. And that's not very hard because it's cheaper to make solar and wind electricity and energy than it is to make fossil fuel energy.
Could we get to 2030?
That would be challenging, but it certainly could be done if there was an emergency declaration, and I think there ought to be, but I'm also realistic that I don't see the signs of that.
So that's like the politicians getting involved.
That's like people realising that we are screwing the one and only planet that we have, and we can't screw it over, then back off to Mars. It just doesn't work.
But I mean, it is a good project also to get to Mars. And what do you think about Elon Musk and all the stuff he's doing?
Fine, it's his money. He can go to Mars if he wishes. He is also making a mighty contribution through Tesla, through the electric vehicle. He has really... we have to electrify transport. And that's 20% or so of all greenhouse gas emissions. And what he has done with Tesla has been monumentally important in putting electric vehicles on the map.
And how's it going with that in Australia? Are there a few electric cars?
Australia is leading in solar and wind and very much at the tail end in terms of electric vehicles. And here, the federal government is just not interested. Some state governments are starting to get interested, and I think that's the way it'll go, that the state governments will start to tilt the balance in favour of electric vehicles. And why not?
I think it'd be great if... or maybe it would help to have these self-driving cars, right? Because then it makes even more sense to get to electric cars. If you can get a ride for cheaper than public transport in a self-driving electric car, that'd be crazy.
Yeah, it's basically all of the above. Shared vehicles, owned vehicles, electric buses, even electric aircraft. I think within a decade or so, we'll start to see significant amounts of short-term electric aircraft. For intercontinental travel, I think that's a long way away and we need a fundamentally different battery, but it's perfectly feasible to make synthetic jet fuel. All you need is carbon and hydrogen. The hydrogen comes from electrolysis of water driven by renewable energy. The only large-scale source of carbon is from the atmosphere or seawater, CO2. But it's not very energy intensive to suck CO2 from the air to get the carbon you need to make jet fuel.
So you're not talking about doing battery-powered passenger electric airplanes? You're talking about...
Yes,
how about those? Can't we just have those for short haul everywhere?
Yes, indeed. For intercontinental, the battery technology doesn't exist. I mean, there is a possibility of using hydrogen directly, liquid hydrogen, but it just seems to me at the moment that the easiest way to do it is going to be to make synthetic jet fuel. So
I think, I don't know the exact statistics, but I think short-haul flights is like half of all kilometers flown or something like that, or passenger flown or something like that. So it's actually a big deal if we could just get short-haul done.
That's right. And also, of course, high-speed electric trains do the same job. Up to 500 kilometers, they easily beat aircraft.
And this other project from the Elon Musk, the kind of like the bullet thing, the Hyperloop, is that relevant for Australia? You want to get over to the other side of Australia in like half an hour?
I think he's aiming more at the 500-kilometre market, San Francisco to Los Angeles, for example. So in Australian context, that would be Sydney, Melbourne, and Sydney, Brisbane, which are the three main population centres. And in the northeast United States, you could imagine it going everywhere. This gets around the problem of cutting a swath right through the countryside of highly secure fencing to keep people off tracks of trains running at 300 kilometres an hour.
And which is dangerous also, and there's a lot of animals that just go in front of these trains, and it's not very nice for them.
Yeah, so if you can put it underground, then great.
May I put a couple of comments? There's one comment from Mike Wilder. He's talking about U-238 and thorium. Is that like nuclear? And what do you think about nuclear?
The solar resource is so vastly larger than all of the nuclear energy available on our planet that we have our own fusion reactor already. It's called the sun, and all we need to do is just collect the energy. It's just straightforward. I mean, the amount of nuclear fuel on Earth is very small compared with what we get every year from the sun.
Australia is one of the major uranium providers, right?
Number 3, I think, or 4, yeah.
But maybe it could make sense to use some of these. They keep getting older, but keep a few of them just also to help in terms of what's it called? Like when there's not enough wind or sun, just in case.
Nuclear likes to run rock steady. The demand is not steady. The solar and wind is not steady. So nuclear is very inflexible. There's also a problem that its scale is just so very, very, very small. Average over the last 5 years, the amount of net new nuclear entering the electricity system is about 1.6 gigawatts per year. This plays 200 gigawatts of solar and wind this year. It's a bit technology. It lost. Solar and wind are just so much bigger than nuclear was and ever will be.
France used to be one of the nuclear leaders, right? But if I look, I'm not totally sure, but I think they haven't built a new nuclear plant in like 30 or 40 years.
Well, but almost
there's got to be a reason for that, right?
Yeah, it costs 2 to 3 times what the price of a solar and wind farm. And I can, as a developer, I can decide I'm going to build a solar wind farm today. I get all the permissions done in the next 6 months, and then 6 months later it's finished. So in 1 year, I go from let's build a solar and wind farm to let's turn it on. And nuclear is 10 to 15 years. It's just far too slow.
Here's one comment. Solar and wind with grid balancing with kinetic and hydrogen. Sorted.
Well, hydrogen is a truly hopeless energy storage mechanism because you have to electrolyze. You have to first electrolyze water to make the hydrogen, then you have to put it back through a fuel cell to get the electricity back, and the round trip efficiency is 25%. You throw away 75% of the electricity, whereas off-river pumped hydro, you only throw away 20% of the electricity. It's simply much better.
So it's 80% efficient. That's really high.
Yeah, and batteries are 80 to 90%. And hydrogen is 25% if you're lucky.
And the off-river pumped hydro, what's the price difference compared to Elon Musk batteries?
Vastly cheaper if you want to do it by the 24 or 48 hour storage. If you want 1 hour of storage, then batteries are going to win. They're complementary. It's not one or the other. It's both. It's pumped hydro, batteries, transmission and demand management. And all of these are off the shelf, already deployed in 100 gigawatt quantities. You just go and do it.
So when the suggestion is to do hydrogen from wind, maybe it could make sense with like like Denmark has this company called Maersk that does a lot of cargo ships around the world. Maybe it could be nice for them, right, to run on hydrogen, or
yes, or much more likely, I think, ammonia, NH3, because it's a liquid at a reasonable temperature, whereas hydrogen is a liquid at minus 250 degrees Celsius. It's simply hard to manage hydrogen. And so when people talk about exporting or storing, they talk about ammonia or some other liquid like that. Hydrogen
or methane, maybe?
Or methane, yeah. But then where do you get the carbon from? It's got to be a sustainable form of carbon. And there is vastly too little biomass that doesn't interfere with ecological values to take carbon from biomass. The only sustainable large-scale source of carbon is sucking CO2 out of the air or seawater. There is no other source. And methane is hard for that reason. Ammonia doesn't need carbon. It's nitrogen and hydrogen.
How about the transportation of methane, or do you call it what do you call it? The other one, I forgot what you what you call it. The one that you think is better than hydrogen. Is it safe to transport?
Ammonia. Oh, ammonia. Yeah.
Yeah.
Ammonia is shipped around the world in large quantities already. It's just a matter of scaling that up. That's not a problem. I just come back again and again to hydrogen is a terrible way of storing energy, but hydrogen is absolutely required for the chemical industry. If you want to make ammonia for fertilizers and explosives, you need it. If you want to get rid of coke out of the iron and steel industry, you can replace the coke with hydrogen to strip the oxygen off iron oxide. Again, you need hydrogen. If you want to make synthetic jet fuel, which is C12H26, again, you need hydrogen. Hydrogen is needed for the chemical industry. It is not needed for transport of energy or storage of energy. You should use the right material for the right purpose.
So that means we can produce a whole bunch of hydrogen with the wind and use it for something specific, right?
Yeah, for the chemical industry. If you want to make plastic or jet fuel, you need hydrogen. And so you have to make it from water by electrolysis.
So we can make plastic with hydrogen instead of oil?
Yes, that's right. So the reason you use oil is it's got carbon and hydrogen in it. And that is used to make the carbon and hydrogen that you need in plastic. Plastic's basically carbon, hydrogen plus impurities, and oxygen as well. Well, you've got to get the carbon and hydrogen from somewhere. If you're not using oil, you have to get the hydrogen from water through electrolysis, and you need to get the carbon from the air by air capture of CO2. And those are the only two really large-scale sustainable sources of carbon and hydrogen for plastics, ammonia, ceramics, synthetic jet fuel, iron and steel, half a dozen other industries.
Nice. So do we have some plastics made of the hydrogen, or it's just a future thing?
It's a future thing. I mean, the technology is not difficult. If you've got a source of hydrogen and carbon, you put them together and make plastic. That's all off the shelf, done at large scale today. The issue is that at the moment it's cheaper simply to use oil or natural gas. In the future, as you're pushing the last uses of oil and natural gas out of the economy, you'll need to replace the oil and gas used in the chemical industry.
But wouldn't it be okay to say that oil for plastic is kind of an okay use, or you think we should rather go to the hydrogen type plastic?
You have to decarbonize in order of importance. So the first thing is to get rid of coal and gas out of the electricity system. Then you electrify transport through electric vehicles. Then you electrify heating through heat pumps and high temperature electric arc furnaces. Then, only then, do you actually have to seriously address getting coal, oil and gas out of the chemical industry. That's iron and steel, ammonia, plastics, ceramics and the like. It's the last thing that you do because it will be more expensive, but that's balanced by the fact that the earlier phases, that's electricity, transport and heating, are cheaper with oil, with coal, with renewables than with coal, oil, gas. And overall, the cost of getting rid of almost all fossil fuels from the economy will be around about zero.
So there's a skeptic in the chat, I think, and there you answered a little bit, right? He thinks the energy density is low, but...
Well, perhaps she lives in Denmark or somewhere like that. Come to Australia. Come to the tropical regions where 3/4 of the global population lives. The density is not low. In Australia, as I've described, 70% of the electricity in South Australia comes from wind and solar, and in the whole Australian grid, it's 30%. And it's going to be 100% within a few years. And this is the future, and it's cheaper, not more expensive.
Is the EU listening to this? Are they going to do the right thing? Because I think it's a year and a half or something that the new EU Commission took over, and they said, we want the EU Green New Deal. But things happen quite slowly sometimes for politicians. So are we doing the changes fast enough?
I think the EU is a master at talk. There's been a lot of barbs aimed at Australia from the EU for not doing enough. Well, Australia is the global leader. Australia is installing solar and wind 4 times faster than the EU per capita. come to Australia and learn how it's done, and come to Australia and see what is done to balance this rapid deployment of solar and wind. Australia has a lot to teach other countries about how to do it. And the important point from Australia is that it's turning out to be much easier and much cheaper than most people believe. Once you start to do things on a big scale, day after day after day, you start to get economies of scale, the price goes down, people learn how to do things, and it's all turning out to be remarkably straightforward.
So you say that pumped hydro could be 97% of all storage?
Well, at the present, it is 97% of all storage. Pumped hydro will be completely dominant in terms of long-term storage. That's overnight and longer. Batteries will be completely dominant for short-term storage of sub-seconds up to an hour or so, and there'll be a mixture in between. Transmission's really important to smooth out the supply, so that when the sun is good here but not there, you can send some solar electricity over by through the power line. Europe just has to get over its hatred or dislike of long distance transmission. If it does not, then you cannot decarbonise Europe. I am so tired of reading about how we're going to decarbonise Denmark or Germany or Britain or France. That is not the right question. The question is, how do we decarbonise Europe? Europe is a country. Treat it as a country.
United States of Europe, that's what I think.
Exactly. I mean, if Texas tried to go it alone, Texas is barely connected to the rest of America. This is nuts. And they paid for it over the last week or two because they're not connected. They can't borrow from their neighbours. High voltage transmission works in both directions. Sometimes, most of the time, Texas will be exporting solar and wind to the rest of the country. Sometimes Texas will want to import solar and wind electricity.
So here there's another comment from David. Chile has a program to make 2050 carbon-free country. Do you want to comment on this?
Yes, I've been to Chile and I've had discussions with the government of Chile, and they're dead right. 2050 will be quite slow. Chile has awesome solar and pretty good wind and vast amounts of off-river pumped hydro opportunities. It's a long country. Basically, Chile has to put a high voltage cable from the top to the bottom, going right through the middle where most people live, and send solar south and wind north, and do the required storage, short-term in batteries, long-term in pumped hydro. Chile is easy, and it's going to be cheap because their resources are so good. And all of the West Coast South American countries are the same. Bolivia, we've just looked at that as well. It's just straightforward, easy to do because they've got such great wind, sun, and off-river pumped hydro. Yeah, this is a map of the United States. You can see the redder the better. So great solar in the west, obviously, and Texas and the other states down around the southwest there have great solar, and they've also got great wind. If you have a look at the wind slide, which is I think next to it, so you can see that there's fantastic wind all the way up the central part of the United States, and it just makes huge sense to have power lines going from that great wind, great sun central area, going west and going east, and picking up pumped hydro storage along the way. There's in the Appalachians and in the Rockies. The United States is spoilt for choice. No technical issues, no cost issues. It's all about not in my backyard issues.
So how do you get all this data? Is it like publicly available, or did you research to figure all this out? Or?
Yes, all of the data that we use is publicly available, including the data that we generate and we mount on our website. So the website that you showed before for the pumped hydro has got a lot of other stuff on it as well. It's got detailed papers, detailed data. It's got a wind map of offshore wind farms, so you can see where in the world is the best place to put your wind farm, with very detailed hour-by-hour analysis over 40 years for how much energy you'll get out of your wind farm. So the United States has got awesome potential on the west and east coast for wind farms, obviously. So when limited potential in the middle, but still awesomely large. The United States has got everything. And Europe has got, importantly, great sun in the south, including floating solar on the Adriatic, where it's protected from major storms, and awesome wind in the North Sea, completely enough for all of Europe if they would just connect north to south.
Sorry.
Can't hear you.
I'm sorry. I muted myself. How about the smart grids? Is that a big part of the equation? And how complicated, how expensive is it going to be to make perfect smart grids? You know, we don't want to have stuff like Texas happen, right?
Smart grids will still collapse if you don't have enough storage. And Texas went through 3 or 4 days with insufficient solar. The wind came back in the first few days. This is where interconnection is really important. So you can spread your risk over a very large area. So smart grids are really important. Australia has got 30% of all households have got rooftop solar. Hopefully by 2030, 30% of houses will have electric vehicles. And if you put the electric vehicle battery together with the rooftop solar system and connect to your neighbours, then you can significantly reduce the overall price and difficulty of managing 100% renewable electricity.
I used to think that the only kind of solution was to have millions of electric cars and have a vehicle to grid and a smart grid. But what you're saying and your amazing maps with all these dots and the potential of doing that, hopefully it's not too expensive. It shows that maybe there's a mix. You can have vehicle to grid, smart grid, and also a whole bunch of pumped hydro. And then you solved, you're 100%.
That's
and
right.
Long transmission. Sorry.
We looked, we looked at carefully at vehicle to grid. We've done 100% electrified transport study for Australia. And it turns out that even without vehicle to grid, which is currently, I think, prohibited by Tesla and some other vehicles, so long as you don't charge during the evening peak period, the impact of the electric vehicles is nil on terms of grid reliability. All you do is you have to expand the electricity production by about 40% to push all oil out of land transport, and that's straightforward. And you just avoid charging during the evening peak period, and everything works sweetly. And of course, if vehicle to grid becomes possible in the future, then that does a fair fraction of the total storage load, in particular for overnight storage.
How likely is it that Europe is going to do those long transmissions? And how quickly do they get to do them? Could they do them like in 2-3 years?
Oh yeah, if you decide I'm going to connect the Adriatic with Denmark and put 500 gigawatts of solar floating in the Adriatic and put 100 gigawatts of offshore wind in the North Sea and connect the two, then around about the 23rd of February 2024, the job would be done. It's just a matter of doing it. There's crazy proposals to turn this wonderful North Sea wind electricity into hydrogen and then pipe it south to places like München. If you're going to put hydrogen pipelines under the ground, well, I suggest you build the pipeline, don't put hydrogen in it, put a high voltage cable in it, and just transfer the direct electricity directly. That way you avoid throwing away 3/4 of your wonderful offshore wind electricity.
This is the huge project from Denmark, right? They want to do the island with that will connect with the huge wind farms. And what do you recommend they do with this?
Why are you making hydrogen? Why not just an undersea cable straight back to north of Germany or Holland or wherever, and then a cable just continues south, over land or underground? And it's not difficult. And you can also take a cable, for example, down the English Channel to France and Spain and get the Spanish sun to match with the North Sea wind.
It might be that actually the hydrogen on this kind of 3D rendering might be actually what could be used for all the chemicals and the plastics that you're talking about and the shipping, container shipping and stuff like that. Maybe airplanes. So maybe it is okay to do some hydrogen, maybe, but not all of it, right?
A vast amount of hydrogen will be needed. It's just important to get it done at the right time. At the moment, the quickest and deepest reductions in emissions happen through pushing fossil fuels out of electricity, transport, and heating. And that does not need hydrogen. And the fourth stage is pushing fossil fuels out of the chemical industry. That needs lots of hydrogen. So talk about hydrogen, think about hydrogen, but for heaven's sake, do the easy things first.
Nice. So you are an optimist, no?
I'm an optimist that solar and wind has won and will win. I'm extremely unhappy that a vast amount of damage will be done to our planet before it all happens. In my country, the loss of skiing, the loss of the barrier reef, the loss of the rainforests is pretty much locked in. What a legacy to leave for our children. How utterly disgraceful. And I, for one, would be 100% behind a plan to do the whole job by 2030. Just get it done.
It would be nice if somebody also invested some billions to try to figure out all kinds of technologies to clean up the sea, clean up the plastic in the sea, and try to fix the barrier reef if there's some kind of way to do that. Do you think it's possible?
The plastics in the sea, of course, is solved by not using plastic or putting silica fill in plastic so it sinks. That at least be something. But in terms of reversing the damage, the obvious thing is to suck CO2 out of the air. And that means that we don't stop building solar and wind when we've got rid of fossil fuels. We just keep building it. And sucking CO2 out of the air is not difficult. It just has to be done on a vast scale. And then we need to, the carbon capture and storage technologies that have been developed for the fossil fuel industry to inject that carbon dioxide as a liquid 1,000 meters down. It turns out that my country has about 3 million square kilometres of suitable geology that is underlying 3 million square kilometres of fantastic wind and solar. And so Australia could do the whole job for the whole world, but it's all about money. Somebody has to provide the money to reverse the damage that we have done. Everything else is band-aids.
And how about planting billions of trees?
Yes, the number one thing is to stop cutting them down in the first place. But yes, reforestation is nice, but it goes nowhere near far enough. The only way to really reverse what we have done, the terrible damage that our generation has done to our children, is to suck the CO2 back out of the atmosphere.
And how about repurposing some of the, especially in Europe, where the farmlands get so much subsidies when we could be farming maybe elsewhere, or maybe farming more smartly or something like that, maybe in greenhouses, or I'm not sure.
Well, the European Union has a completely stupid bioenergy program. The notion that bioenergy is a sensible solution to climate change is farcical. It's greenwashing on a vast scale with enormous damage. The fact is that photosynthesis is about 1% or less of the efficiency of a solar collector. That means you need 100 times more land. You also need lots of water and pesticide and fertilizer, none of which a solar collector needs. It's absurd to use biomass as a way of addressing greenhouse issues, except by converting your biomass farm to a tree farm and storing the carbon long-term, like over thousands of years, as a mature forest. In other words, reforesting farmland that's not needed for food. Farmland used for energy is a crime, in my opinion.
It's a little bit weird that they're pretty much like burning up trees as part of the biomass or something like that. And
it's fictional.
Yeah, it's a little bit hard for me to understand what's the point. But it sounds like the trillions of dollars in the oil industry and coal industry of the last century. It seems that maybe the people involved in that want to continue that some kind of way. Maybe that's why they're thinking hydrogen, because it would be a way for them to control supply and transport and sale of energy.
Yeah, it looks like natural gas, but natural gas has had its day.
So when you talk about these amazing projects, those are projects, or they're really happening?
There's the Snow 2.0 is really happening. Billions of dollars are being spent right now. The other pumped hydros, there's a dozen or so of them, are most of them under serious detailed planning. Battery of the Nation and Kidston are probably the first two that would get the nod. But there'll be a couple more years, I think, because they're not actually needed until Australia gets up towards 100%, which won't be till the end of this decade, not the early part of this decade. So that all of these adaptations are needed as you move above 50% renewables, which is still a few years away.
But these investments are in the billions and billions and billions of Australian dollars and euros and US dollars. But you are saying that you can calculate. I hope my sound is still on. You can calculate that the price is for sure that low, $35 after all these investments.
This is not a calculation; it's the observed price. In South Australia, with 70% solar and wind, the observed price is $35 megawatt hour. So this shows how absurd all these prognostications about how hard this all is and how expensive it all is going to be. Facts on the ground: $35 US per megawatt hour for 70% solar wind penetration in South Australia, and it'll be the same for the rest of Australia, and it'll be the same for the 3/4 of the population of the world that lives in the tropical and temperate areas, and it'll be the same for Europe when they get full-scale access to the offshore wind.
All right, so this.
Come to Australia and have a look what's happening. Facts on the ground trump political rhetoric, or they ought to.
It's nice to see some optimism in terms of what could happen and some examples of what's happening. And there's a Danish model and the Australian model, and hopefully we can all just connect and make sure that there's power all the time, everywhere, and just more power, because so many people in India, Indonesia, and all these other countries, they want to get a luxurious lifestyle and have TVs and projectors and smartphones and everything.
Well, we looked at Indonesia. It's the world's number 4 country for population. It's a very densely populated country. And we looked at 100% renewable energy in Indonesia when Indonesia catches up to the United States and Europe in terms of per capita energy consumption. And all oil, gas and coal is pushed out by full renewable electrification. In other words, the amount of electricity you need goes up by a factor of 30. And we found that Indonesia has completely unlimited places to put this extra solar panels, and that's in the inland sea. In other words, floating solar panels, which is off-the-shelf technology. It turns out that the Indonesian inland sea never sees a hurricane, never sees waves over 3 meters height, never sees wind over 15 meters a second. And so all this inland sea here in the tropical region is available, and they've got 100 times more sea area than they actually need to get to 100% renewable energy at the same per capita level as you or I enjoy. Indonesia does not have a siting problem for solar.
Nice.
And it's also got completely unlimited pumped hydro opportunities.
Nice. There's a lot of hills and mountains. They can just build these.
Yeah.
Is there any chance this pump hydro can be really affordable to deploy?
Yes, it's only $1,000. $1 billion per gigawatt, and this. When you look at the cost of a fully renewable system, about 2/3 is the solar and wind, and about 1/3 is the balancing, and that is equally transmission and storage and spillage of wind and solar occasionally. So storage is expensive, but it's not very large fraction of the total cost of a fully renewable energy system.
So when you build like a gigawatt through nuclear, it costs a lot more?
A lot more.
Is there a way to quantify this? Like, is it like 10 times more?
You won't get a gigawatt for $1 billion US of pumped hydro storage, and it'd be multiples of that for nuclear. Multiples.
10 times maybe. Because if some no-brainer kind of calculations out there, things might get even faster, right?
Yeah. Well,
that's what you provide. That's what you provide. All your presentations are like no-brainers, right?
Yeah. I'm puzzled often by the way that people talk on and on about this or that wonderful new technology that we're going to develop and invent, and it's going to cost such. But all the technologies we need are available off the shelf right now. The solar and the wind and the pumped hydro and the transmission, they're all at 100 to 1,000 gigawatt scale already. So there's nothing to invent. Just go and do it.
One thing that I've been wondering is what's the what do you call it, the maintenance cost? Is there like very modern wind and solar that last for like decades without maintenance, or is that just a dream that's not real? That you have to go around and like brush the dust off, or what do you have to do?
You'd rarely do that. Typically, you'd assign 0.5% to 2% of the capital cost as a maintenance fee. Higher for wind, lower for solar, similar for pumped hydro. So all of these technologies are expensive upfront, but very cheap to run. Once you've built them, pumped hydro, most of it will last 100, 200 years. You'll have to replace the genset after maybe 50 years. Solar will last 50 years in a dry location, less if you're close to the sea. Wind would typically last 25 or 30 years, but you might repower the wind. You might take down the wind turbine and put a much bigger one in its place in a couple of decades. So they're long-lived assets.
They're definitely not like something that needs to be fixed every 2-3 years at cost.
Oh, I hope not.
That's like some argument that some people say, right? But it's not true, right? You say 50 years for the solar. Doesn't it burn up or something?
In a dry location, and you'll lose 0.5% to 1% of its output every year. And maybe after 30 or 40 years, you'll think, okay, these steel frames that the panels are sitting on have still got another 50 years in life. So how about I dump the panels and replace them with higher power, newer panels? That's just an economic calculation. You could leave the existing panels there and they'll just keep on generating, losing a little bit each year, but keep on going.
How about those huge solar kind of like mirror things that I think they do in the US? Is it also happening elsewhere, or is it a good idea?
No, the technology failed in the marketplace, and the global market for solar thermal is approximately zero.
Is that thermal, these things?
Yeah, they're solar thermal. So it's reflecting sunlight up to a central receiver, which gets very hot, and you run a steam turbine off the central receiver.
Okay,
but solar PV just undercut their price and killed them.
All right, cool. That's awesome. So, how about the Chinese? I go to Shenzhen a bunch of times. Are they really doing this thing where the Xi Jinping or the previous guy that was there before hits on the table and say we'd make it a priority? Are they really doing this? Are they like going big time into this like they should, or they should do much more? What do you think? And they're also manufacturing a lot of the solar, right?
Yeah, so on the last point, China is the dominant solar PV manufacturer, but that doesn't mean that they will be in the future. In terms of planned economy and planned decisions, China has pledged to get to net zero in 2060, which is too slow. They've got the world's best combined solar, wind and pumped hydro resource, and it'll be easier for China than most places to get to net zero in 2040, and they ought to do it. Interestingly, Korea and Japan both made pledges to get to net zero emissions in 2050, and that means a lot of offshore wind for both countries. And the Biden administration looks like it's gearing up for a similar declaration, net zero in 2050. The Europeans actually need to get serious about their rhetoric and get serious about transmission and get serious about getting rid of their stupid biomass and investing in offshore wind and in the north and solar, floating solar in the south, and just do the job. Just stop talking about it, get on and do it.
It would seem that it's a no-brainer for countries like China to want to dominate the future. This is like a market, right? Everybody wants to buy these solar panels. Everybody wants to buy these batteries. So are they are clearly investing a lot, but they should invest like twice as much? Or why? If it saves so much money, having clear skies and everything, why doesn't it just happen much faster?
Well, come to Australia and see what happened. We have a hostile government, and it's happening. A free market does help often, because the government doesn't have all the ideas, but China does have the capacity to be the battery for Asia, where most of the world's population lives, because Western China has fantastic solar, wind, and pumped hydro resources, and it is not so far from India and Pakistan and Bangladesh and a whole heap of other countries that are have more people per square kilometre than China has, perhaps. And yeah, so China really could be a global powerhouse, or almost certainly will be a global renewable energy powerhouse, but it needs to do it faster than it's planning.
How about India? I've got so many viewers from India. I think they're connecting to the internet like in really fast. They got really good internet and everything. But how about great power for everybody in India, and with a pumped hydro? Is that also relevant over there?
Yes, India has good wind in the northwest. It's got great off-river pumped hydro throughout. Vast amount in the Himalayas, of course, but it's also got a lot in the south. And you can go to the Indian map and zoom in and in and in, and you can see that there's lots and lots of sites down in the south. Of course, there's great solar in the south, and the solar is not too seasonal in southern India. So there's no reason that, well, India is moving fairly quickly to a solar-dominated new generation capacity system, but it needs to go quicker and basically stop building fossil fuel power plants, just solar and wind with pumped hydro backup, so that the growth and growth and growth in the electricity market in India is met from solar and wind, not from coal.
Do you need to bring this water from the sea?
No, the amount of water required is absolutely trivial. The same water goes round and round and round a circle, so you don't actually consume water. You do need an initial charge, and if you build a pumped hydro system over, say, 30 years, to service an electricity system where everyone's got the same standard of living as in the United States or Australia, you need about 3 litres per person per day to do the initial fill and to replace evaporation. So it's quite a small amount of water.
Because one of the big reasons we need a lot of power, I guess, also in the future is to desalinate seawater. Maybe that's also very relevant for places like India. Yeah.
Of course, the desalination would just be done in the day, and the storage would be in the form of clean water rather than energy, which is much, much, much easier.
All right. I mean, this is so fascinating. I'm so excited about this pumped hydro potential. Are there many researchers talking about this, or are you in the forefront of all this pumped hydro?
Definitely in the forefront. We've done a global atlas, which is getting about 15,000 hits a month. So a lot of people are looking at it, engineers and the like. In Australia, there was a perception that hydro had done its day. Australia has very few rivers, and it was agreed that there'll be no more dams on rivers. And then we came along and said, well, hang on, 99% of Australia is not near a river. So let's have a look for all the Australian sites. And we found vast numbers, and it had a major impact. Our paper was read by the Prime Minister at the time, Malcolm Turnbull. This led to the Snowy 2.0 pumped hydro system that's being constructed now. And there's a dozen serious pumped hydro systems being developed in Australia. None of them involve a dam on a river. So within 1 year of us starting to talk about it, it flipped. And one of the reasons for that is Australia is developing wind and solar so much faster per capita than any other country, and it's simply more urgent in Australia than in other countries.
When I look at this area here, northern part of Europe, Eastern Europe, Russia, so they would have a lot of wind, right?
A lot of wind. Oh, not in the east, not in Russia. Russia is not well served by wind, but the North Sea, northwest, is great.
So what is Russia going to do? They're going to import. They're just going to have high transmission lines coming from everywhere.
They could, but Russia's a small country. It's only 150 odd million people. There are a few countries where it's a bit difficult. But Russia has solar in the south, quite a lot of it, and vast areas to collect it. So, and it does have some wind, and it's not beyond the capability of the Russians to build the solar and wind farms and connect using high voltage power lines. Russia, of course, is going to lose its gas market in Europe as Europe moves to renewables. And so Russia, it has to be said, is not a winner from the renewable energy revolution.
They're really eager to get their pipelines back up running in Ukraine to deliver and also they built this Nord Stream to deliver gas to Germany. Mm-hmm. But Germany should just get on with doing a lot of wind, right?
Yeah, Germany needs to do three things. Stop politics getting in the way of energy planning, get serious about offshore wind, and get serious about connecting to the south. Whether it's overhead power lines or an underground power line, doesn't matter, but it's not difficult technology. It's a tunnel through the Alps, and there's lots of tunnels through the Alps already for roads and rail, and just put a high voltage power line down that tunnel. It's not difficult. Just do it.
Can you have a high voltage power line underground, or it has to be on these cables up there mostly?
It can be underground or on cables or undersea. So one way, if you just scroll a little bit to the west, you could bring North Sea wind down the coast of Spain, Portugal, France, and service all of the western countries of Europe. Solar going north and wind going south. For the Mediterranean countries, that's Italy and the Slavic countries, floating solar in the Adriatic has unlimited potential. There is low wind always in the Adriatic, so the engineering required to protect the floating solar is not expensive, and you've got awesome pumped hydro opportunities to the east of the Adriatic, and Italy also has a fair few. And then you just put a cable from the north of the Adriatic through to Germany and then on to the Low Countries and exchange southern sun for northern wind. And you just forget about hydrogen.
It makes me want to look up who's the energy commissioner of the EU. It's got to be some kind of dude or a woman that's it just needs to like say, come on, let's figure it out together. It's always trying to be they're keeping their independence or their sovereignty, but it's not the point. Just build this thing, right?
When you talked about the Danish energy plan. Well, that's as sensible as having the Victorian energy plan in Australia. The Victorian energy plan heavily relies on connection to Tasmania, South Australia, and New South Wales. If you fail to connect to your neighbouring countries, then you will multiply by 5 the amount of storage you need. It just makes everything so expensive and so hard. And then you start thinking about ridiculous solutions like using hydrogen to transfer and store energy. Just use off-the-shelf technology, wind, solar, transmission, and pumped hydro, and just do it.
What should Ukraine do? It doesn't look like there's a lot. There's some over here, but they have some mountains, no?
Yeah, Ukraine has some pumped hydro, or not so far from it. And the southern part of Ukraine gets into good solar regimes, I don't think there'd be a lot of wind in Ukraine. I don't recall clearly. But Ukraine needs to talk to its neighbours, the further south it goes. Now, Turkey, for example, an undersea cable from Turkey
I can't see Turkey. It's just full of dots.
Yeah, it could easily feed all of the. Turkey's got great wind and great sun, and unlimited pumped hydro.
So let's have Turkey and Ukraine join the EU.
Yeah, that's right. And they don't have to join, of course. They just need to, connect with a cable.
Yeah.
Russia is part of the EU, but it's connected with a pipeline, and gas goes one way and money goes the other.
And the Middle East, Saudi Arabia is like second biggest oil reserves in the world. Iraq, there's all these stupid wars going on for decades. They have lots of sun. Just like use it, right?
Well, actually, their wind is fantastic too. There's great wind all across that whole peninsula, and so they're absolutely spoilt for choice. And they've also got, surprisingly, fantastic offshore, fantastic hydro opportunities. The United Arab Emirates, for example, up in the north east there,
they have mountains.
They have mountains, yes, and they've got some quite good sites. So pumped hydro is the worst place in the world for pumped hydro is in fact Northwest Europe, the Low Countries. That's the only place in the whole of the world where there's a serious shortage of pumped hydro opportunities, where a lot of people live.
How about those energy transmission cables? Do you have to replace the network that's already there, or just build on top of it? Or is it like new high power, and is it more or less easy to figure out where they should be?
All of the above. Technically, it's easy. You just say point A to point B. Then you consider practical limitations, and you might decide that you'll repower an existing easement because it's much easier for people to accept a higher power cable than a new cable. Also, you think about offshore wind running down the English, in cables running down the English Channel and down the coast of France, and you consider underground cables, which are much more expensive than overhead cables, but are the solution if you simply can't get around the NIMBY problem.
And the UK can just have rain power, right? I'm joking. But they have lots of wind, lots of wind.
They can't have rain power because they have very few mountains, so hydro doesn't really work, except up in Scotland. But Scotland's got great pumped hydro, and there's a bit in Wales as well. So Scotland's probably got 4 or 5 times more pumped hydro than the United Kingdom needs as a whole country.
But so we can just make a deal, and these countries up here make a bunch of wind. These countries do the pumped hydro and the solar, and just connect, and then the whole thing is solved. And we can do it in 10 years, right? 5 years.
The Slavic countries are currently the poor cousins of Europe. Well, guess who's got the pumped hydro and the potential for floating solar? It's the Slavic countries. They are going to be the energy superpowers of Europe.
How about this whole Greece area with a bunch of islands? They've got wind also, right?
They do have wind. It'll be offshore. So I mean, the southern part of Europe can go it alone. It doesn't need the north. If the north wants to actually have a sensible energy system, it needs to ask politely whether the south is willing to share some of its sun and pumped hydro.
I think Europe needs to help out Africa, and has responsibility in doing something, and maybe in some kind of Europe has always been taking advantage of the mining resources and all that stuff. Now they can take advantage of their solar power a little bit, but at the same time provide them all with power.
North Africa, if you zoom into the northern part of Africa, Algeria, Morocco, has not just great solar, it's got great wind, really good wind off the Atlantic, and great pumped hydro. And if this were to be connected to southern Europe through undersea cables, completely off-the-shelf technology, then it would hugely stabilize the politics of Northern Africa as well, because now you've got money flowing back down the cables. Electricity goes one way, money flows the other. And this will be an enormously valuable contribution of Europe to the stability of North Africa.
I mean, there's no such thing as free energy, kind of, but maybe it should be free energy and free water and like a human right, and just get it done.
Well, the thing about solar is that it's now, solar photovoltaics is now the cheapest energy in history. This is not my words. This is the words of the latest International Energy Agency report. Solar power on a large scale in a good place now is coming in at $30 US per megawatt hour, and is going to end up, I think, at about $15 or $20 per megawatt hour. This means that solar power is available almost everywhere for a price that is below what you could ever do with fossil or nuclear. It is an enormously important development for human society.
All right, so we've got an exciting decade and a few years ahead to see if these things happen with just market powers, with the capitalism, the thing we have going on, or if politicians need to come and hit on a table, or a combination of all this, right? There's always a combination to get things to happen, right?
I'm a technologist. This is all straightforward. I'm not a politician. I don't understand how politics works.
Yeah, it's impossible to. There's no science in the politics. It's just like some kind of weird theology or something.
Yeah, that's right.
All right. So thanks a lot. Thanks for your time. Thanks for transmitting this feature film on my YouTube channel. Hopefully, million people will watch, or thousands. That'd be nice. Thanks a lot, and hope to see a success out of the global 100% renewable energy. How long time have you been talking about this 100% global?
I was a technologist to about 3 or 4 years ago. About 4 years ago, I realized that we were now moving towards 50 or 100%, and we needed to really focus in on what's required to get there. And storage seemed the obvious shortcoming. Off-river pumped hydro storage solves that problem. And it fits with my philosophy, which is, preserve our beautiful planet for our children. It's been a stimulating interview. I've really enjoyed it. You've asked a lot of good questions, and it's been great.
Thanks a lot. And one last little thought I had when we talk about the ecological impact. Sometimes people think about all these frogs and the insects and all these kinds of animals. They might really enjoy all this off-river pumped hydro places with water. It might be good for them, because you might be doing these in the middle of the desert or stuff. It might actually help create new oases.
It could be, though they'd have to get used to the water level fluctuating by several meters per hour as the water goes up and down.
Right. Okay.
So it'd be quite turbulent.
It'll be a ride for them then. Okay. Yeah. So thanks a lot. Thanks for your time. Thanks a lot.
Thank you. Bye.
Thank you.